So it's going to be a combined talk. The talk topic is from idea to market, joint development and fabrication of leading edge thermopile arrays. Guys, so you have a total of 20 minutes. We take a couple of minutes here to get going. So it's going to be very important that you stay on time. So it's going to be about 15 minutes is the speaking portion for both of you. So, so Thomas, please, let's stay on time, and then for Jorg as well, we'll need to make sure we stay on time so we have plenty of time for the break and lunch. So again, welcome to you both, and I think we're all set to go, and please go ahead.
Yeah, so thanks Mike for the intro, and also good to get the technical things fixed quite well and quick. So my portion of the talk today will be on Fraunhofer IPMS. So as everybody should know, we are supposed to be the R&D partner of this conference here. And of course, in my talk, I will briefly focus a bit more on the Fraunhofer IPMS and its capabilities, specifically to support small and medium enterprises as well as startups in the field of MEMS engineering, MEMS technology, and MEMS low volume manufacturing. So that's basically what we can offer as a service. In general, Fraunhofer IPMS is striving to be a world leader in research and development services for electronic and photonic microsystems. And we are specifically dealing with the application areas or fields of industrial solutions, quality of life, and medical and health. And Mr. Schieferdecker afterwards is going to present in the third area, medical and health. So we will hear about his presentation regarding application of thermopiles. Fraunhofer IPMS has 450 employees. Actually, we are supposed to grow this year close to 500 employees. We have an annual budget or turnover of 42 million euro. Half of the money is coming from contracts with industry partners. So we are pretty strong in cooperating with partners from the industry. We are owning a 200 millimeter wafer fab for microsystems, specifically MEMS, photonic MEMS, which is my responsibility. And we also have a 300 millimeter wafer fab for microelectronics, which is not a part of today's talk from my side. Our business model that we are supporting with our clean room is basically covering TRL levels from 3 all the way through 7, potentially also 8. So basically we can support partners and customers with research and feasibilities, targeting MEMS and MOEMs. So MOEMs like micro optoelectromechanical systems. We are doing design and process development. We are doing demonstrator to prototyping and also pilot manufacturing. And we could support customers also to transfer the process to a high volume manufacturing foundry, for instance. So that's what we can offer as a service. For that, we do have a fully integrated and CMOS compatible 200 millimeter clean room. We are running R&D and pilot fabrication at the same time. So we consider ourselves a low volume, high mix fab. We are running at 24/5, 5 days a week at 24 hours with a 3-shift operations approach. My division has 45 engineers, most of them being process engineers, and 45 operators and maintenance technicians that are keeping the clean room up and running. Lithography wise, we do have 365 nanometer i-line lithography as well as 248 nanometer deep UV lithography, enabling us to go all the way down to 110 nanometers lines and spaces resolution. We are doing about 1,000 wafer starts per month. As I mentioned, we are CMOS compatible, so we are doing basically MEMS and CMOS integration in most of our activities. We are having a clean room class 10 or ISO 4 on 1,500 square meters. We are fully certified by ISO 9001 2015. And most important for quality and also for cycle time reasons, we do have a manufacturing execution system for planning, traceability, and documentation of our process activities in the clean room. We do have, let's say, state-of-the-art 200 millimeter process equipment. We have converted our clean room 3 years ago towards 200 millimeter. So for all the major areas like lithography, plasma etch, deposition, and so on, we do own equipment that is basically standard equipment from the industry. We have also improved in the last years with capabilities in the wafer-based backend activities, supporting our internal and external customers to go more towards system solutions. That's maybe also important to mention here. And as a selected highlight, starting this year, and meanwhile it's up and running and integrated in the first process flows, we do have a 200 millimeter, 248 nanometer DUV cluster consisting of a Nikon S210D scanner as well as a TEL track. And I think for MEMS, MOEMS, R&D as well as pilot manufacturing, this is quite some, let's say, state of the art, and maybe not everyone can offer that service. All the details and the features of the equipment you can see on the right side, so I don't want to spend too much time on the details here. From our technology capabilities, we basically have three major approaches that we can support in our clean room. So first is we do surface micro machining, specifically for micro mirror arrays and for CMOS. So for CMOS, you can see in the picture on the right some example here. Some SEM picture showing the membranes of the CMOS. We are doing bulk micro machining that is being used specifically for micro speakers and for scanning micro mirrors. And also, of course, as I mentioned already, we do MEMS on CMOS integration in active as well as passive devices for thermopile arrays. So this is where Mr. Schieferdecker is going into some deep dive, as well as for micro mirror arrays. Like for instance, here you can see one micro mirror and the underlaying CMOS drive with the capacitor plates and with the hinges. So one of these little mirrors is 16 by 16 microns, and we can do devices comprising up to 1 million of these little micro mirrors, each of them being deflected individually. So this is one of our key capabilities and key knowledge that we can offer. And two examples, let's say from the customer side, or at least from here, in this case, it's more on the development side. One example I can show here is what we consider one of the next big things in micro optoelectromechanical systems. So it's supposed to be a phase modulating micro mirror array for real holographic displays. This is currently a EU Horizon 2020 project that has been started last year. Beginning of this year, is supposed to be running until end of 24. It's comprising also a consortium of different partners, 8 partners from 6 countries in the EU, and it's currently starting at TRL 3. It's supposed to go the way to TRL 5, and the status is that design phase has started, as you can see at the bottom, and the initial chip manufacturing has started in my clean room, and the application that it's supposed to be targeting in that project is a pilot and a showcase for a head-up display in automotive, so in the windshield of a car. The good thing is it's what we call real holography, which is eye fatigue proof and real genuine image quality in real time. So not what we are used to from television at home, but it's the next level. Another project that is already at TRL 7, it's also with automotive. In this case, it's a solid state LiDAR system for autonomous driving. The customer that we have here, and we can also mention, is the company AI from the United States. Continental has been buying into that startup company Q4 last year, and the market introduction of this system in our device is supposed to be in 2024. As you can see at the bottom, there are quite some impressive features that have been achieved already. So the range of the system is going up to 1,000 meters. It has a high frame rate, and pre-series manufacturing of the micro mirrors has started in my clean room as well. And as I said, this is already at some high TRL level and supposed to be going productive in 2.5 years from now. That is some overview from my side. And here I would hand over to Mr. Schieferdecker, the CEO of Heimann Sensor in Dresden, one of our long-term and most important customers that we have from the industry side. And he is giving some insight into the thermopile application.
Great, thank you very much, Thomas, and Mr. Schieferdecker. Again, welcome. And if you could launch your slides now.
Okay, I just tried to release them, so I hope it is released.
Yeah, I think they're coming up. Here we go. Beautiful. That's great.
Okay.
Excellent. And then, yeah, so to stay on time, let's aim for 6 or 7 minutes, and we have a couple of minutes for Q&A.
Okay, I try my very best. My name is Jörg Schieferdegger. I am the CEO of Heimann Sensor. This is a mid-size company in the headquarters in Germany. And in Dresden, we are a world market leader in infrared thermopile arrays, have over 250 employees and manufacturing sites in Europe and Asia. And we have a bunch of different sensor products for single detector and array detectors for infrared imaging. Now I want to concentrate on the medical application rather than the technology. One of the main applications, especially in the last year and this year, was to measure the elevated body temperature to detect fever as a consumer application. We have been almost 30 years dealing with single infrared thermopiles. Everybody knows ear thermometer or the forehead thermometer to measure body core temperature, and that is running in several 10 millions per year in a nearer distance to the forehead. And about 5 years ago, we started the first 8x8 arrays to measure from a larger distance, like 30 to 60 centimeter. But still, that was not enough for the needs to measure body temperature accurately from a distance. Here, what we see is some funny stories about the so-called fever screening in the media. It seems to be trivial. Some operator is pointing to the forehead of a person and right in the middle, and then he measures the body temperature accurately. Unfortunately, that is not the case, since there's not necessarily the higher temperature. The winner is, you see this in the news, even such paper was shown, a photo where the people even measure the mask. Of course, this is absolutely ridiculous and far from correct, because the mask has a much different temperature than the body. Anyway, we want to check how can we do it more accurate. Of course, infrared array imaging forehead skin temperature measurement is not accurately a fever detection nor the evidence of COVID-19. For that is necessary to have accurate body temperature measurement, and medical test is needed. However, they can give a hint for the potential risk of fever. Why is that the case? One side you see here is taken with one of Heimann Thermopile Arrays to see the temperature distribution on the skin, on the body. And you see just in the middle of the forehead where these blue circles are seen, that is not the highest temperature. You see more on the side, or especially in the so-called tear ducts of the inner eyes, you have much higher temperature, which are much closer to the body temperature. And you have a kind of special signature. Every person may have a different temperature signature. So if you don't have enough pixels on your forehead and on the face, you can't measure accurately. Some elevated body accuracy problems. Problem number one, the core body temperature, that is typically 36 to 37, if you're not sick, is not equal to the forehead skin temperature. That is typically 1.5 to 3 degrees lower. And a strong aircon makes even bigger differences. Problem two, the measured temperature decreases with increasing distance between the thermometer and the body. If the body goes more far away, the hotspot is smaller, covered by less pixels, and atmospheric absorption effects. So all this has to be taken into account. The problem three is, even for high pixel count infrared arrays and imagers, the hottest spots on the forehead may be at the side, inside the ear or tear duct, or these areas must not be covered by hair or glasses. And finally, people entering the building from outside at temperature well below or above the room temperature, then the skin temperature has to adapt, and that takes a while. Also, that leads to wrong measurement. Some examples. One of the examples for very high accuracy, this is done with infrared imaging cameras with VGA resolution 640 by 480 or even higher, like 1024 by 768. Infratech is one of the examples where you have a very high resolution and can measure accurately the tear duct. So they may achieve 0.3 degrees C, especially if the position is fixed. So the person you see is standing like on a mark and in a very correct distance from the infrared thermometer. That is a very accurate way. The classic approach, many people traveling, especially in Asia, have seen that. You have a crowd measured by an operator at the airport behind the gate, and you can measure many people at a time. It is not accurate, but you can pick up people which have, let's say, higher than 35 degrees C on the infrared image, when the probability is high that they have fever, and when they are selected and measured outside. The medium cost approach, C, is to use since anyway this option A to B with quarter VGA. Now I hear my own voice from 2 slides before. I'm not sure what that means. Anyway.
Jörg, we can hear you. We can hear you fine. It sounds like maybe the echo is on your side, but we can see everything.
Okay.
We can hear you fine. There's no echo.
Anyway, so back to here, you can have an maybe 80 by 64, 120 by 84 thermopile array already to measure up to 3 people at the same time in front of such a fever screening device. And the accuracy is not very high, but at least you can measure. You can increase the accuracy by having a reference black body. You see here's a reference black body in the scene here, like where the arrow points to, and that you can use to compensate for some other drift effects. And finally, the big challenge, especially in the last year, was the fever screening of many, many people at the entrance of train stations, schools, hospitals, and so on, especially in Asia. And you see here at all these entrances, you have one of the cameras that needs a very big amount. And also Heimann was making in the last year some 1 million plus of such infrared low-cost imagers, typically with 32 by 32 pixels only, and to measure that. And here as an example, many of these different types of pen type displays combined with an infrared array from Heimann, and next to it is usually a CMOS camera, because the device is also showing you whether you have a mask on or off, and tell you you're in good temperature or you have elevated temperature, you're not allowed to proceed. So these are some of the examples. And to come to the end, to be in time, some words to the cooperation between Heimann Sensor and Fraunhofer IPMS. So Heimann and IPMS are in intensive cooperation for the last 20 years. And the success factors for the joint development are the direct neighborhood of both partners in the Dresden so-called Silicon Saxony. That is our Silicon Valley of Europe. So we are at no other European location more wafers, silicon wafers processed as in the Dresden area. And here we are together with a foundry. All this is within a few hundred meters away. This is one of the key factors. Furthermore, IPMS has intensive MEMS and silicon technology know-how and makes this available to us. And we combine it with a comprehensive experience in R&D and the manufacture and technology of infrared sensors and their application. And that allows us to have a very fast development cycle to turn new product ideas coming from Heimann and ideas how to make it with some IPMS know-how into a pilot run. Pilot runs are often at IPMS or partly IPMS in Heimann, and continue with a mass production in Heimann later on if the volumes are big. This cooperation was the key factor for reaching about 6 years of advantage of Heimann thermopiles over our competitors. And you see it that while we develop already generation 1 and reach higher and higher technology readiness level for product 1, the second product is already started and launched. And you see it here from about 15 years ago, we had a first 8x8 arrays, followed by 16x16, 32x32. Also well over 12 years, 10, 12 years we have it, but in this year or last year, it was really booming due to this COVID-19. 80x64, that is when opening the door to the infrared imaging. Our highest in the production is now 120x84. And we are working on 160x120. That is image of that, but this is not yet in production. This is just a development process by now. So this is the roadmap, what we are doing and what's going on. And so this was my part. And not sure if Thomas will say some additional words to it. Anyway, from our side, this cooperation between Heimann and Fraunhofer was really a success story for both.
Okay, all right. Well, great. Thomas, Jörg, thank you very much for the talks. So again, it's very good to hear about how Heimann Sensors has been working with Fraunhofer, and it's a great example. Appreciate you sharing the case study. Thomas, also thank you for highlighting the capabilities of Fraunhofer and highlighting some of your very exciting companies like AI. It's great to know that you guys are working with AI on LiDAR applications. So we don't have any time for questions, but we encourage everybody to reach out to Thomas and Jörg to discuss further. There's also the booth, Fraunhofer's booth on Brella, so please check that out as well and connect. Again, Thomas, Jörg, thanks so much for your talk and sharing your insights. We really appreciate it.
Thank you.
Okay, thank you.
Thank you very much. Have a great afternoon.